All right, everybody. So we've been spending a lot of time coming up with strategies for solving systems of linear equations and thinking about how we can express the solutions in different ways. So I think it's important to just pause right now and think about, well, why are we studying linear systems of equations? And the answer is because they are everywhere. And so we'll take a look at a couple of examples of where linear systems of equations arrive in the next couple of videos. The first example I want to take a look at is with economic modeling. We'll also take a look at an example of a network flow looking at the traffic patterns in Baltimore. But these applications of linear systems are everywhere throughout sciences and social sciences and data science. But the first example I want to take a look at is economic modeling. And this is based on the work of Vasily Leontief, who was working at Harvard University in the 1940s. So in 1949, he wanted to come up with a model for the entire US economy. And so he worked with 250,000 data points that were produced by the United States Bureau of Labor Statistics. And what he found is he divided the US economy into 500 different sectors. And we'll see what some of those sectors might be. And at the time, Harvard had one of the world's highest powered computers called Mark II. And the Mark II could not even process this much information at that time. So if you're curious what Mark II looked like, here's a picture of it. And just a side note for the Mark II is the first computer in the history of the world that actually had a bug. And it had an actual bug. A moth flew inside this computer and was causing it all sorts of problems. They were able to figure out that it was a moth, and they cleaned it out. And that is why some people suspect the term a computer getting a bug has come from. But in any case, in order to solve his problem, Leontief had to therefore simplify, make some further assumptions, and reclassify the system into 42 different sectors. So he had a linear system of 42 equations with 42 variables. How long do you think it took Mark II to solve that system? Well, this model was what was known as the Leontief production model or input-output model. And so this system of 42 equations with 42 unknowns that he derived, it took a good solid weekend for Mark II to solve that system. It took 56 hours for that to be solved. And such a problem nowadays would probably take a minute to solve on a computer. And people have been working with linear systems of thousands and thousands of equations and unknowns. So Leontief's model was a little bit oversimplified due to some of the technology constraints that he was working with at that time. Okay, so to get a sense of how the input-output model works, let's simplify the 500 sectors that Leontief identified in 1949, and let's just make a very big oversimplification of the problem. And let's assume that instead the US economy is divided into just 3 sectors. Let's say we have a renewable energy sector, an electricity sector, and a manufacturing sector. And for each of these sectors, we can measure the total output for the year. So let's say, for example, and this is roughly based on the data that Leontief actually used from 1940. I think the data he used was from the US economy in 1947. Of course, there were no renewable energy at that time. But let's say the renewable energy sector has an output of 40, and this means 40 billion US dollars. And let's say the electricity sector has a total output of $100 billion, manufacturing $125 billion. And these sectors are all interrelated, right? So in order to create electricity, partly that would be due to some renewable energy, and then that electricity is used to produce goods, manufacturing. Some of those manufacturing goods are used in the renewable energy sector, and so on. So what we want to model here is how are all of these different sectors related to each other? And so another important component then is to think about, well, out of all of the output of renewable energy, how is this distributed amongst the other three sectors? And we can summarize all of this information in a table that we'll call an input-output table. And so let's make sure we're reading this correctly. So the renewable energy sector, they created 40 billion US dollars of output. 10 billion US dollars went back into the renewable sector. So they were using some of their own energy to create some of their output. So that's 25% of the total output from renewable energy went right back into the same sector. 25 billion US dollars were used in the electricity sector. So that's about 62.5% of the renewable energy output was used in the electricity sector. And then the remaining 12.5%, which is 5 billion US dollars, was used in manufacturing. So here we're assuming that this economy is made up only of these three sectors. And so whatever was produced by renewables was used by one of these three sectors. And similarly, the next row in the table tells us that the electricity sector had 100 billion US dollars of output. And we're assuming here that $7 billion were used in renewables, 18 in electricity, and the vast majority of that was used in manufacturing. And the same, the last row is doing a similar breakdown for manufacturing. If the total output in the year was 125 billion, then we can see how that was split up among these three sectors. So I've got absolute totals provided, and I also have relative totals, the percentages beside them. And so on the next slide, we're going to convert this input-output table to what's called an exchange table. And essentially, we're just going to be focusing on these relative amounts as opposed to describing things in absolute amounts. Okay, so we are going to convert that input-output table from the previous slide now into what's called an exchange table, which just is going to give us the proportion of the output from each sector that is consumed by the other sectors. So we have the renewable energy sector over here, and we can see that out of the renewable energy output, 25% of it is being purchased by renewable energies. 7% of it is being of the electricity output is being purchased by renewables, and 16% of the total manufacturing output is being purchased by renewables. So this is telling me how much output renewables purchased from each of these different sectors in terms of proportions here. So when we look down each of these columns, these are all adding up to 100%. So here are all of the renewable energies output, and we can see 25% goes back into renewable, 62.5% goes to electricity, and the remaining 12.5% goes to manufacturing. So everything, 100% of the output is being accounted for in this table. And some terminology that the total dollar amount that each sector's output is called the price of that sector. So for example, I believe the electricity sector had 100 billion US dollars of output. So we would say the electricity price in that year was $100 billion. And so we'll use P sub R to denote the total output from renewable energy sector. P with a subscript of E is the total output of the electricity sector. And here PM is denoting the total output from the manufacturing sector. And Leontief proved that there exist equilibrium prices that can be assigned to the outputs for each sector. And what we mean by equilibrium in this sense is that the total income, so the total amount that that sector produces, in other words, the price of that sector perfectly balances out its expenses. And he was able to find these equilibrium by setting up and solving a system of linear equations. So in the next couple of slides, in the next video, we're going to set up the system of equations for this economic model, and we're going to find the equilibrium for this economy.